Hello, my name is Pranav Gadaraju,
I'm Eric Stoll.
And I'm Rishi Vandanori.
and we are Team Prime. We're competing in challenge number 4, which is to design a low-cost means for providing distilled water to healthcare facilities in remote areas of the Dominican Republic.
We started our project by researching the pre-existing healthcare system. The Dominican Republic has a total of 445 hospitals, including both public and private institutions. They have made efforts to improve their healthcare system in recent years, but challenges such as limited resources and disparities in access to healthcare still exist. The Dominican Republic's total GDP is 94 billion, but they only spend about 4.3 billion on healthcare. This is less than the recommended 5%, which is not ideal for a country that's in need of adequate healthcare.
One of the biggest challenges they face is the limited access to distilled water. Non-distilled water or water that contains impurities can cause corrosion and damage to equipment, which affects lab tests and sterilization process. Patient safety is also at high risk due to insufficient sterilization. Additionally, small healthcare facilities face increased costs from purchasing distilled water or replacing corroded equipment. To combat this concern, we would like to reduce replacement costs of equipment that can be damaged or corroded by impure water. We also want to improve sterilization equipment maintenance and effectiveness to ensure proper sterilization and enhance patient safety. Our main goal is to enhance the overall quality of healthcare services in the Dominican Republic by implementing a rainwater collection system with a solar thermal heater.
Here's a brief introduction to our solution. The first step is the system will collect rainwater, then it will be stored in a chamber with a water level valve. Sunlight will then pass through the glass roof of the chamber and heat the water, while mirrors focus solar energy for increased heating efficiency. And lastly, the steam generated from the heated water condenses back into distilled water, which is safe to use, and it is transported into another cooler chamber.
So we started by researching the weather patterns in the Dominican Republic, and it tends to be pretty warm and sunny, but it also rains every 2 to 3 hours, which you'll see later, but it goes into our design, which is in this box right here. And here's a more expanded version, and it has three main parts: a water collection system, a water distillation vessel, and solar thermal mirrors. The collection system acts as a large funnel to collect rainwater and filter out particulate matter through the mesh that's on the top. The water from here then leads to the distillation vessel, which is heated in two ways. There's a glass roof on the top to create a greenhouse effect and maximize the heat from the sun. Then there's aluminum on the bottom to conduct the heat from the solar thermal mirrors. It also has a valve which controls the amount of water entering and an exit tube for the water to condense in. The solar thermal mirrors work by reflecting the light from the sun onto a concentrated point on the bottom of the vessel, which is made of aluminum, which will conduct enough heat to make the water boil and then therefore distill the water once it condenses, which then can go into the hospital.
Our solution will impact many people in the Dominican Republic that struggle to access good healthcare. We found this estimate to be 1 in every 3 Dominican people out of the 11 million population. Our solution will also benefit hospitals because they won't have to purchase distilled water and replace damaged equipment. By lowering the operational costs of the hospital, they will be able to provide better services to the general population and reduce high out-of-pocket costs of patients.
Knowing that many people around the world struggle with healthcare issues, we felt that using a sustainable or natural design, thermal energy, would better help these third world countries rather than using a more industrialized design. One challenge that we faced was deciding the best solution to the problem, as we had many potential options. There's only one area where the water accumulates, which means we are not maximizing the efficiency at capturing rainwater. But as a team, we felt that this solution outweighed the other cons of the other proposed options.
One thing we would do differently is try to get feedback on our design and see what others think can make it better. Moving on to motivation. We were exposed to new information about different regions. This is very rewarding because it gave us newfound perspectives about the struggles of many third world countries.
We chose EWH because we love the values of what they strive for, so we decided to join because we wanted to develop our engineering and design skills while gaining knowledge that can be applied to the real world. Here are the resources we used to guide our research. And thank you for watching.